All right, cool. So if you guys have looked at the project at all yet, you'll see that you can either use scraping or an API to get information, right? So the whole point of the project is to use good OOP principles and get information from over the internet in some way to instantiate the custom objects that you make, right? So you do have a choice whether to use an API or scraping. We're going to talk about APIs today. And if you look at the video I posted, that will cover how to scrape. So hopefully you'll have both. And I think the curriculum goes pretty in depth in scraping as well. So, so definitely look at my video if you intend on doing scraping, you just want to learn more about it. I also do kind of a cool little OOP setup. Make a few classes that use inheritance and to make a random wand generator for Harry Potter themed as always. So it's pretty cool. I would check it out if you're interested in that kind of thing. But today we're going to focus on APIs and we're going to be doing Pokemon. A little resumption of what we're resuming, whatever, I don't know if that's a word. But we're going to resume what we did last time. We're going to use the classes we made in Tuesday's lecture. We're going to pull information from the internet and use that to instantiate our objects and go from there. And I did also post a video doing a little bit more from the code from Tuesday. Hopefully you guys were able to see that. If not, I didn't do a whole lot, so hopefully it's you won't feel like you don't know what's going on. So give me 1 second to pull the slides up, which I should have been doing while I was talking, but I got lost in talking, and then we'll get started. We're going to start looking at the same slides that the intro to scraping video starts with, but we're not going to get too deep into them. Once it starts going off on the scraping tangent, we're going to stop. So let's do it. Share screen. All right. Let me know when you guys can see my screen. You see it?
Yeah.
All right, very cool. Okay, so so obviously we're not going to be doing intro to scraping. We're going to be talking about APIs, but there are a few things that I want to talk about first. So was it? Yeah, okay. All right, so first thing, I want to talk about some of the basics of how the internet works, because it's really, really easy to get scared about the internet and make it like think that like it's all this like magical stuff happening. And it is actually really cool, a lot of complex stuff, but having a good understanding of the basics, so you get a gist of what's going on, is important. And I think that we should talk about it now. And in pod groups later, if you guys are interested, we can do a deep dive into a lot of the nitty gritty of how it works. But for now, let's just talk about the basics. So HTTP, can anybody describe what HTTP is? Not even necessarily what it stands for, but just like what it is generally. You guys can all see my slideshow, right? You're looking at this screen, right?
Doesn't it stand for hyperlink? Hyperlink something protocol, right?
Well, since the second letter's T, I'll say that you might be close, but not exact, right? Hyperlink would probably be HL, right?
Oh, well, yeah, I mean, obviously. No, it's hypertext. No, I got it. It's hypertext. Hypertext. Oh God, what is it?
You're close.
HTTPS. Hyper.
What are you doing with that hypertext?
Hypertext texting people.
So close. Transfer protocol.
Right? I knew that.
All right. All right, cool. So HTTP is just a like hypertext transfer protocol, fancy word for I have a bunch of a bunch of computers. Those computers are connected, and I want to get information from one computer to the other, right? In order for computers to talk to each other, there have to be a set of rules, right? And this is no different than talking to people. Like you and I are conversing right now because we are operating under the rules of language, right? And customs, right? So you knew that if you wanted to get information from me, you had to go onto your Zoom, you had to open up the link that you should all have, just the same link every time for this meeting. And you come into Zoom, and then once you're in Zoom, right, I will be talking to you in English, right? So those are the rules under which we're communicating at this point. You have to know English, you have to have Zoom installed, and have to know where to go. And so we're now communicating effectively based off of a protocol, right? You just might not have thought of it that way, but we do have a protocol established so that we can communicate with each other. The internet's the exact same way, right? I can't have two computers talking to each other if they don't have a protocol, a set of rules to know how to talk to each other, right? So computers, right, operate on a very, very base level, operate with binary data, ones and zeros, right? The only way ones and zeros can make any sense is if we designate very strict rules about what ones mean what where and what zeros mean what where, right? So if I have, like, for example, HTTP, There's a very strict set of bytes, like the first X bytes mean this, the next X bytes mean this. We have a set of rules that turn ones and zeros into letters, right? So humans can read what it means, all that kind of stuff. All these rules play together to make it so we can effectively communicate, okay? So I know I just said a lot of stuff, but basically HTTP, you can think about HTTP as just being a set of rules that allow us to have, for us on our browser to go request a website from another computer that's hosting a site. So it lets the internet work. When you go into a browser, you type in google.com, you're sending a request using HTTP or HTTPS, which is just a secure version of HTTP, okay? Any questions about that, like very basic concept? The HTTP is just the rule set that allows you to request sites from other computers. Does that make sense?
I mean, to dumb it down, would it just be something akin to we all understand each other because we're adhering to English grammar rules? Otherwise, it's just gibberish.
Yeah, and I think that would be good. If you want to get more technical, it might be like HTTP might more be like the combination of the English language and like customs when you say hi, like me saying, oh hey, what's up, and now I have your attention, and now we engage in a conversation. That's kind of going to be what HTTP is like. Okay, like you know what to tell me because of what social customs. When I say, oh hey man, what's up, and I like tap you on the shoulder or something, you know that I want to engage with you, and so you turn and now we're having a conversation. That's kind of what HTTP would be.
Okay.
Cool. All right, so so what happens when we load a web page in our browser? Okay, what we do when we like type in google.com and click enter, we perform what's called an HTTP GET request. There are different types of requests. We're going to focus on GETs for now. We'll come to find in later sections that we'll talk about posts, patches, deletes, and even some other stuff. But for now, we're going to worry about GETs. GET request means that you on your browser want HTML or information, some sort of text-based information back from a site, right? So when I go to google.com, actually, let's do this. All right, so actually, I guess I want to go into the basics here. So really what's happening for all of you that are kind of like me, where you have to like bridge the gap between what's actually happening and then the big picture of what's happening. So we talked about the big picture, I'm making a request. So in reality, what's actually happening is our computer is outputting over a series of like electrical, light, or EM wave signals that either gets propagated through the air or goes into some, fiber optic cable or some, normal electrical cable. And that signal, right, that electrical signal somehow makes it to another computer. And that signal will represent a series of ones and zeros, right? So that's like base level what's happening, okay? And again, eventually, like I said, those ones and zeros that are interpreted by that electrical signal or the light signal or the EM wave signal, that will get turned into text, which together represents a GET request or some sort of request from HTTP. So don't worry about the whole electricity thing, but for those of you that like to know, like how am I just like making a GET request magically? Really, at the very, very base level, you're talking about like literally a light signal or a EM wave signal, right? And ones and zeros, because they follow the protocol. Now, the protocol that turns ones and zeros into strings is different than HTTP, but they're all like, we have a set of rules or protocols that eventually make whatever I send across the internet understandable by another computer. Okay, so the GET requests are to go back to high level, like bird's eye view, right? So we have a when I put in like google.com into my browser, I'm making a GET request. That means that Google knows that I'm not trying to like change its database or anything. I'm basically just asking Google a question and it's returning text to me. Okay. The server, Google's going to give back to me what's called HTML and CSS. Now, normally when we talk about scraping, these two are very important, right? Because you're going to, from the HTML that gets sent back, you're going to get information from that if you're scraping, and you're going to use what's called CSS selectors to find the information that you need. This is very, very important should you scrape. With an API, it's much less important. API stands for Application Programming Interface, and we're going to talk about it more in depth in a second. It's a general term, and it also has a specific meaning. We're going to talk about a very specific meaning of it. But basically, the great thing about API, instead of giving back information, like, so when I go to google.com, it's giving me back information that's meant for me to view visually as a human in the browser. So when we scrape information from a website, the server isn't giving us information to scrape. It's not, the intent is not for us to scrape it. The intent is for us to view it as humans. So scraping it is difficult because we're taking something that's intended to be viewed and we're trying to like grab the specific information we need from that like big mess of HTML. API is great because API is meant to be read and used by other programs. It's not meant to be read and used by humans like visually. So APIs are nice because they're already coming to us in a very bare bones fashion that's made for us to use in programs rather than HTML, which is not made for that. So we'll see that in a second. So let me real quick. Any questions? Who knows what HTML is? I'm using a lot of words and tricky phrases here. If I say something you guys don't understand, please cut me off and ask me questions. So who can tell me what HTML is without reading the thing I just put on the screen?
I was going to say hypertext markup language.
Okay. And what's it for?
So when like you have a website, correct me if I'm wrong, it's kind of like your tags and stuff, like your CSS is your design as far as like what the page looks like, things like that. And then the text behind that is your HTML as far as like links and things of that nature.
Yep. And it's all just like,
HTML.
it's all, you can think of it as like one big string, right? So it is just text. It just follows a very specific format, just like any programming language, I guess. But it's a markup language. So HTML defines the structure of what the page should look like. And CSS defines the styles of like the colors and the positioning and all that kind of stuff. And what our browsers do is it looks at these two sets of text and they interpret it in a visual way. And we'll take a look at what that looks like in a second. Again, I don't want to spend too much time on this because we're going to talk about APIs today. But like if I went to Google and search something right here, I don't get back like this looks all nice for me, right? But this isn't like what Google's sending to me. This is what my browser interprets what Google sends to me. This is what Google sends to me. And this is even like a nicely formatted version of what they sent. Imagine this all is just like one big string, one big line of text. This is what they're sending me. And then my browser says, oh, I know what to do with these things. I know to like read this style and interpret it, meaning like it should be in, in a certain position in the page. I know what divs should do. I know what, all these things. Like I know what a is a link, right? So I know that should be a link. And then if you click it, you should go here, right? So all of this raw HTML that Google's sending back gets interpreted by my browser to look like this, right? So when I make a GET request to a web page and I get back HTML, it's my browser's job to make it look good. This is the information I'm getting back. So when you're scraping, you're going through this raw information and you're trying to figure out what information in this text do I need to like put into my objects? What information do I need to like grab? Do I need to cherry pick from here, right? APIs are different because APIs give us that data straight up without all this other stuff, without any styling. APIs don't care about styling. They don't care about positioning. It's all about the data. That's what APIs are made for. So you'll be using more APIs. The reason that, so allowing to use APIs is relatively new and the push towards it is relatively recent in Flatiron because you will be using APIs more. I do think scraping teaches you a lot, but will you be scraping frequently? No. So it's really up to you guys. You'll learn a lot by scraping about how stuff works. I would say it's a little bit harder because you have to like really find out where the information is that you want. That's the benefits of scraping. The benefits of using an API is that you'll be doing it more. So it's a more valuable skill, I guess, because you'll be doing it more. And it's easier. So it's really up to you guys. I'm not saying one's better than the other. It's really up to you. I could go either way with it. All right. Anyway, any questions about HTML and like just the very basics of like what it is? Okay, very cool. All right, and I think I kind of want to stop here because from here on we're going to be talking more about scraping stuff. And I had such a cool little here. Watch that video if you guys want to see the little challenge that we had for ourselves. Anyway, so let's do this. Let's go ahead and talk about what we just said. So when I go, let's recap. When I go to google.com, all right, I've just made a GET request across the internet to a computer somewhere in some Google warehouse, that a computer that knows what the HTML is that should be returned when somebody wants to go to google.com. So they return to me this. This is what they gave back, okay? And let's see if I can actually find a better representation of it. Let's refresh. There we go. There we go. That's what it looks like unformatted. This is what was given back to me, right? This is the information that makes my browser display this, okay? Look at all this stuff, all right? And then if you scrape, this is what you'll be looking through to get the information you need. Now, there are libraries that help you do it pretty nicely, but here we go. So this is google.com. And then the nice version of it looks like this, where I can kind of like see what does what. You see, I have nice little like highlighting on my screen, right? So again, the hard thing about scraping is that this was sent to me, not for me to pull information from it. And obviously I would never pull information from Google. I'd probably like go to Wikipedia, I don't know, or at some site. Actually, what we did in the scraping videos, we went to Pottermore.com and we went to like one of the Pottermore pages that talks about wands, and then we use that information, right? So, but I think this will be a good indication. Like obviously this site, all of this data is not meant for me to grab information from it from an application perspective. It's meant for me to look at it like a human and figure out like what is it that like I want to look at it and like read stuff. So let's see, what is it, like wands, Pottermore wand. Let me find the exact site so I can show you guys. Very cool. Here we go. So this is one of the sites I used, right? And so as you can see, like when this site comes up, all of this information here is not meant for me to go in and grab it with a language. It's meant for me to be able to read it and for it to look cool, right? So that's the big difference between scraping and APIs, is that this is made for human consumption, human eye consumption, while APIs are meant for program consumption. So let's look at our API and what that looks like. All right, so I'm gonna say Pokemon API, and the first thing we're gonna do is not really an API. It's gonna be a little API tester, and it'll tell us what the API actually is. All right, so it's telling us if we go to this /Pokemon, we should get some information. And that's why I really like this site, because it kind of gives you like a little fake one first. All right, cool. So, so I'm still going to make a GET request, okay? The only difference is that this site, unlike Pottermore, is deciding to instead of returning HTML to me, which is made to be, you know, visual, it's returning something to me that is meant to be used by a program. This is pure data, right? And if you saw for a split second, it just looks like text. That's what it was. I have a little Google Chrome extension that makes it look nice so I can see it. But as you can see, this information, when I go to a site that's strictly meant to be an API, I get back raw data, which it's very easy for me to use in a program, right? So this is the nice thing about APIs. APIs are I'm still making HTTP GET request, right? I'm still requesting information from pokeapi.co. Okay, and they're still getting that GET request saying, okay, he wants this information and sending information back. The difference is they're sending me, in this case, what's called JSON, JavaScript object notation, which kind of looks like a hash, right? You can think of it as like a hash with some arrays in there, okay? We'll talk about JavaScript obviously later on. But they're saying the API site's like, oh, okay, this person doesn't want to like look at Pokemon and read about them. They want to use my data in their own application. So APIs are specifically for you consuming this information in your own application. Does that make sense? Any questions about that?
What Chrome thing do you have that does that for you if we're going to be needing something like that?
Yeah, let's see, JSON viewer, Chrome. I don't know what it's called. If you just like Google search like Chrome extension for,
okay.
yeah. Oh, it was called JSON viewer, I guess. There's a bunch of them, honestly. I don't think they're really any different. Just Google search like Chrome extension for viewing JSON, something like that. You'll find it. But yeah, so do you guys get that? What GET requests are? The fact that like, you know, wizardingworld.com and pokeapi.co, like all of these things, every time I put these in my browser and click enter, I'm sending an HTTP GET request, and they're either giving me back, in the case of this page, right, they were giving me back HTML. Right, so if I look at the elements here, I got HTML. Actually, let's look at the network tab. Oh, all right, let's refresh. Here we go. So here's their response. Here's the HTML they sent back to me, okay? Here's the HTML they sent back to me. If I go here and look at the first one. All right, so here's the information that they sent back to me, okay? All right, but then when I went to it, so this is, again, no different. I still do a HTTP GET request. The difference is that this site did not return HTML to me. They knew, because this is an API site, they knew that I didn't want HTML. I didn't want to look at it. So they sent back to me instead this JSON, okay? Which is text that's formatted that make it very easy for me to use this in my own code. Right, because if they brought this back in HTML, I'd have to search through the HTML elements I wanted to get this information, but this is just straight up information. Does that make sense, everybody?
Yeah.
Okay.
Mhm.
All right, cool. All right, so let's get into it. Let's do some coding, and yeah. So let's see here. So when you guys hear like HTTP, I don't want you guys to get scared. So this first project, we're not going to talk about like HTTP too much, but come Sinatra time, if you guys don't fully get HTTP, like that's the main thing I fail students on for the Sinatra. Now I'm not going to be doing your Sinatra review, so lucky for you. But when I do fail people, it's because they can't describe that stuff to me. They don't. If you don't understand the basics of how the internet works, you're never going to be a good developer. It's just that simple. So take the time to really understand how this works. So, okay. Cool. All right. So let's go ahead and just start in a new. Where are we right now? All right. All right. Pokemon object relationships. So let's go cd ... Let's go into. Oh my goodness. Ah! Okay, so this is what I'm saying. I click enter instead of backspace. All right, it's already getting bad. We're going to my other keyboard. All right. All right, there we go. All right, let's connect up. There we go. All right, so we'll go into intro to APIs, I believe is what I called it. Is that what I said? Oh, lessons. Intro to API. There we go. Cool. And so we'll also make a directory called live lecture, and we'll start here. All right, so what's the first step that I have to do if I want to get information across the internet? Just generic. What do you guys think?
Type in a website.
Okay. Yeah, exactly. I need some way to make that GET request that my browser does, right? So when I type the URL here, that my browser does the GET request for me. So I need some version of that. I need Ruby to somehow do what Chrome just did for me, right? That's like step one of getting the information, right? So let's go ahead and wait for VS Code to pop up eventually. And let's look into how to do that. So there are a few ways we can do it. We're going to use something called HTT Party. It's a nice little Chrome or a nice little Ruby library out there, a little Ruby gem. Find HTT Party. We can take a look at some of the docs for it. And once you guys get comfortable with like trying new stuff and looking at the docs, right? Not every gem is awesome, right? Like anybody can make a gem. Like I've made a gem, just like put it out there, and I don't really maintain it. So if someone uses it, it's probably on them. So you got to be careful. One thing to look for: large number of commits, recent commits 8 days ago, a lot of contributors. So this is probably a pretty good gem, right? All right. So what we want to do first is install it. I already have installed, but you would say gem install HTT Party. Okay. And here's some examples, and this is all as complicated as we're going to get today. Okay, we're not going to do a bunch of like including HTTP Party. All we need to do is use the class method .get to perform an HTTP GET request and put in the route. That's as simple as it's going to get, or as hard as it's going to get. It's going to be that simple. So let's go ahead and just give it a shot. What I am going to do though is, because we're using good object-oriented principles, I'm going to say I'm going to encapsulate this stuff inside of a class. Okay, so I'm going to make a class called API Manager. And I have a decision to make now, and I don't want to talk about this too much, but I could instantiate this and make it like instance methods and make it instantiatable. However, I'm only really making requests to this Pokemon API. So I'm actually going to make a bunch of class methods that I'm going to call. And you could really go either way here. So this is one of those times we've talked about, like, when do I use instance methods, when do you use class methods? This is one of those times where it really could go either way. But we're just going to use class methods today because one of the things I think about in my head is like when you instantiate objects, you give each one the ability to be unique. Do I need unique API managers? And the answer is no, because they're all going to be requesting the same stuff. So there's no reason for me to make these different objects because they're not going to be unique from each other. Okay. Now, when I have a bunch of Pokemon, those are going to be different from each other. So I will make those, right? Obviously, Pokemon will have instance methods and be able to be instantiated. So that's the difference there. All right, so I'm going to say def self dot, and let's say get Pokemon, okay? And I'm going to make a class constant called base URL. And set that equal to the string. And the information I want is this information right here, right? All this stuff. This stuff I'm seeing right here. So this is the URL I want to go to. So the API says, and now the thing that's really cool about this Pokemon API is it lets you kind of like mess around with it here, and it tells you like what to do. So I can like say Pokemon / Arcanine, right? And that's how I get information about just Arcanine. I could say Pokemon. I get all the Pokemon, and it's paginated, so I only get 20 at a time. Okay. And we'll talk about pagination in a second. Hopefully we can get to it. Do I have a new pod group after this, don't I? Yeah. All right, pod group. As always, we might go over a little bit. I'll make up the time in the back end for you though. All right, cool. So starting off, and guys, remember, please stop me if there's anything you have questions on as we do this, because I know this is brand new, and I don't want to like make the assumption that you understand something that you don't. So please, please, please ask. And I don't always check the chat. I'm seeing it's flashing now, so I will. Yes, Cody. Yeah, that is a correct evaluation on the situation. All right. My dad's British. What do you want from me? All right. So my base URL, pokeapi.co/v2. All right. And to get all Pokemon, the route is /Pokemon. So let's take one quick second to talk about why that is. We're going to get into this later on, but let me you know what? I'm kind of debating whether we should do this. Okay, there's this thing, RESTful routing, that defines like which routes give you what stuff. So if I say / and then the name of the resource, it means I want all of those, all of the things of that resource. If I say like Pokemon /3, it means I want the Pokemon with an ID of 3. Okay, so that's the convention we'll come across later, right? They also let you search Pokemon by their name, so I could say Pokemon /Arcanine, right? But this convention of like the resource name and then / something specific about that resource, that's going to be something we see later on. So just remember for now, if you want all of something, you just say / and then the resource name. That's going to be pretty standard. And then if you want something specific from there, it's usually going to be an ID number. So like Pokemon number 95. And it looks like I got, who did I get here? Some stone Pokemon. I don't know. Oh, Onyx. Okay, cool. All right, sweet. So any questions about that? Just like basic convention. Usually / and then the resource name will give you a list of a bunch of them, and then / after that / view specifics.
Is that just specific to this website?
No, this is called RESTful routing. Almost every website should follow this convention. Every API you work with will be similar.
Okay.
Okay. Cool. All right. So I have my base URL is the thing up to, but not including what I would type in to be unique, right? So to get all Pokemon, I know I want to say /Pokemon, right? I want to get this data, which I just got in my browser, okay? So I'm going to say response equals HTTP party, and let's require it up top. Okay, so I'm going to say response equals HTTP party dot get, just like we saw in those example docs, right? HTTP.get. And I'm going to put in my base URL plus /Pokemon. And I could have also just interpolated here. I just decided to use string concatenation instead of interpolation. It's fine, doesn't matter. All right, and I'm going to say require pry, and we're going to take a look at what this looks like. And I don't know why I'm keeping the screen so small for you guys. Sorry about that. Let's see what we just got here. Okay, so I'm going to say Ruby API manager.rb. And I'm not going to do anything because I never called the function. All right. See, even I make that same mistake sometimes. All right. So hold on one second. What do I want to say here? How do I call this get Pokemon method? Pop quiz.
Get _ Pokemon.
Okay. And what do I call it on? The API manager, or do I have to say .new?
You're not instantiating it, so you don't have to put .new.
Exactly. And how do we know that we don't want to instantiate it?
Because it's not going to be an instance; it's a class.
Yeah, exactly. It's a class method, self.getPokemon. So I know I need to call it on the class. Everybody tracking that? All right, cool. I hit my binding pry. Let's look at my responses. And there, look at that. It's that simple. There's all my information from the internet. So httparty.get has gone across the internet, performed a HTTP GET request to this URL +/Pokemon, and I've gotten the first 20 Pokemon. Okay. Now that's all well and good, but what do I do with this information, right? So this is where we're going to start talking about what we should be doing with the data, right? So it's all great to have a hash, but we learned OOP for a reason, and so we can utilize our data in a really cool Ruby-esque object-oriented way. So I'm going to take that. I'm going to take those objects that we made last time. Hold on 1 second. Those are the ones. Those are the new ones. I want to get the old ones that we made. All right, let's do this. CD into OO relations. Open this up, and we'll take what we did last time, and we'll put those classes, just really just kind of slide them over in here. So we have a trainer, we have the world, and we have our Pokemon. I also made this fire Pokemon if you guys watched my video from last night. Cool. All right, to review what we have so far, right? Our Pokemon gets instantiated with a type, a name, and a gender. Okay? And that's the create, but it's the same thing down here with the new for initialize. Okay? It's going to start off at HP of 0 on a level of 1. No trainer. Okay? And I put some information, I put some new stuff inside the trainer to get a starter Pokemon, and we've turned our catch into a private method. And if you guys are confused about this, just watch that video. We still have our trade Pokemon from last time, and we made this little throw Pokeball method, which actually implements probability into should we catch this Pokemon or not. Okay, so if you're interested in that, go ahead and check that video out from last night. Otherwise, we're just going to move forward, and we're going to utilize these classes with this information here. Okay, and we're going to see what we can do in about 25 minutes. So we have our get Pokemon method. Okay, and we have a bunch of data. So the question is, how do I get this information and turn it into an object? What do you guys think? Well, what should I do here?
Iterate over it?
Okay. What would be a really elegant way, or what would be an elegant location to iterate over these and to instantiate a bunch of objects? What entity? Like, remember, you're the god of the universe. What entity should be in charge of this?
Pokemon demigod.
Yeah, the Pokemon demigod. I think that's exactly what I would do. I would tell the demigod, hey, dude, so I am going to get a bunch of information about Pokemon from the internet, okay? And I want you to be able to take that information and turn it into Pokemon objects. Self.create from API. And I'm going to get, what information is going to get passed in from here? What data type is this? Let's say if I took the results key.
An array of hashes.
Exactly, an array of hashes. So let's make my variable name array of hashes. Okay. Very explicit data types, right? Just remind you guys, always ask yourself the question, what data type am I working with? Very, very important question. Okay. So I want to go through this array of hashes, and I want to instantiate objects from this information. Okay. It looks like they're calling the name what I've called the type. So we're going to have to deal with that. And they are also doing something with the URL. And this is actually going to be important because the only information we're getting from this request to just get all Pokemon is literally the type of Pokemon it is and then a URL. And that URL is important because check this out. If I go to Bulbasaur's URL, let's copy this and paste this in our browser. So if I go to Bulbasaur's URL, this is how I get like all the actual information on him. Right, so his abilities, his forms, like all of the, anything I could ever possibly want to know about Bulbasaur is here. His move sets, right, all the information about those moves when he learns them, right? So this URL is important because it's how I can get more data about this Pokemon. So I could really build up my classes and make like probably a playable Pokemon CLI application with all that information, okay? Because I literally have everything I could possibly want. Cool. So I need a way to take this data and save it inside of my objects. So I heard iterate. I think that's a great idea, right? I have an array of hashes. So I want to take an array of hashes and turn it into Pokemon objects. So I'm going to say array of hashes dot each do. And what am I going to get? What's going to be in my pipes here, guys? What kind of data? I have an array of hashes. I call it dot each on that array of hashes. What is each element going
Get
to be?
a key value.
What was that?
You're gonna get a key value.
Okay.
Okay.
Yeah, a hash, right? A
Yeah.
hash representing a single Pokemon. A Poke hash, maybe? Okay. I think so. So we're going to get a single Poke hash, right? When I go through this array of hashes, right? What am I going to get one at a time? Well, name Bulbasaur URL this. Name Ivysaur URL this, right? I'm going to get a Poke hash. And I want to take that Poke hash and I want to turn it into an actual object. So I think I will say, why not tell my, well, let's make it into another method. Why not? I'll tell my Pokemon demigod, create from hash, Poke hash. All right, so now this is where I need to try to bridge the gap between the type of data I'm getting in and how it looks and how I'm currently instantiating my Pokemon objects. So I can either change how I do this, which I actually probably will do, or I can change this, which I probably also will do. So I need to find some common ground to get this information into my object. So the first thing I'm going to do is something you guys might not have seen yet. I'm going to give these, what am I doing here? Does anybody know what I'm doing right now?
Making those symbols.
Keyword
Okay.
argument.
Yeah, so how will this be different when I actually instantiate a Pokemon object than before? When I put this colon afterwards, what does it do?
That makes it so that it's not dependent on the location of
Yeah.
it, and you can also assign it into a variable, so you can use a Poke hash as a variable input for when you initialize it.
Exactly.
Whatever
That's
you
it.
called it.
That's exactly right. So I'm going to take out this Arcanine thing. Let's stay with Pokemon objects for now. So before I was doing this. So I was saying the type was Arcanine, and then it was the name was Griffin, and the level was 1. Okay, so that's how I was doing. No, it wasn't level. What was the third one? Gender. That's right, male. Okay, so this was how I was doing it before. When I change my arguments and put my colons afterwards, like Eric said, like no longer do I have to maintain the order, but I'm doing that at the price of having to specify the key. So if I were gonna instantiate Arcanine here, I would say type Arcanine, name Griffin, gender male. Now I could put this in any order. Because it knows which one I mean, I could do this just fine. So the benefit is that I don't have to remember the order. It's no more explicit, so it's very clear to whoever's reading this, like what each value means when I'm instantiating. And the other nice thing is I could also say this, GH equals some hash where name is Griffin, gender is male. So I just make a hash, and type is Arcanine. And I can instantiate this with my hash because the keys match the keys required here. And notice too, third piece of the puzzle, I can still do default values with this. I just do :nil instead of equals nil. All right. So I still am able to do default values, but now I require, when I instantiate, I require a key, but it gives me the added advantage that I can instantiate with a hash. And that's why we're doing it here. That's the big help, because this is a hash right here, right? So now I can instantiate this with a hash. Now, what do I need as well? I wanted to instantiate with a URL. So let me add URL, give a default value of nil. Now that's going to be one of my possible things that come in, okay? And I could mix and match here, right? So I can say, you know what, the type doesn't require a key. I always want to say type. And then I would go over to my world, and this would be like, I would have to put type first. So I can no longer do it like that. Let's go ahead and put these back as arguments though. So if I did it that way, I could do our canine as the first argument. And then everything else could be named arguments like this. And again, that relates to this syntax here, where I can mix and match between some not being required to have a name, but the position then becomes important because it has to be the first one. And then the rest of them do require a name, and they're all optional. So when you're doing more complex classes, this is actually pretty cool. I would probably do this a lot. If you know, like, it's very clear that a Pokemon needs a type, so I would just make that unnamed in first because everyone knows what that is. And then all these other little things that come in would be named. We're not going to do that today. We're going to make type named, but we are going to not give it a default value because I definitely need a type when I'm making it. And we're not going to instantiate the way that we do in World. We're going to instantiate via our API. So I'm going to comment out all this stuff. Any questions about that? I kind of just like rapid fired at you guys for a little bit. So let's field some questions there.
Just a few. When we instantiate through the hash variable that we assign, right? So P1, do we have to ensure that the readers and writers also match up to the particular keys and values that we're doing? And do we also have to do the instant variables as well and make them all kind of cross-reference?
Yeah, so you definitely want to, like, I definitely want to add like an @URL here now that I've added that, if that answers your question. The readers and writers should always match your instance variables. Your instance variables do not have to match your input variable names, right? They usually do, but the hard rule is that these should always match your instance variable names. I could have called this like some URL as long as like, so this would work fine. They had to put some URL in there. I'm calling it @URL as long as @URL matches URL here. Right? Now we're good.
Yeah.
Okay. Now I'm not going to do that because some URL is silly, but do you get my point?
Yeah.
Okay, cool. Another thing is that a lot of people ask, you know, like, do I need to maintain, like, if I pass in a hash, does it have to be the same order? And the answer is no, right? Hashes don't maintain order. Hashes, let me say that again, hashes do not maintain order ever, right? So that's why they're key value pairs. The value is determined by the key, not by some order. So by making these named, I no longer care about the order in my initialize, and hashes generally don't maintain order. So it doesn't matter what order you make your hash. All right, cool. Alrighty. What are we doing? So I changed this to accept a type and a URL, optionally a name and a gender as well. Setting my instance variables, I've updated my attribute accessor for those. Now what I have to do is I want create to follow the same convention. I want everything that goes to initialize to go into create. So I'm going to copy this argument list, put it over here. Because remember, create does exactly what new does, except it also saves, right? So I'm going to call new with the type. Then I'm going to have to say type, name, gender, URL. All right, now we're good. All right, cool. Any questions on why we just did that or the mechanics of that setup there? Please let me know if there are. This is a lot. Again, I'm shooting a lot of stuff at you. So, what's up?
So can you please go up to like line, yeah. So on line 11 or 12, would that be like a good time to meta program it and use the .send?
If you're gonna .send, I would do it in initialize.
Okay.
So the way that and we can do that here. Let's do this without .send, and then let's refactor it with .send. Okay, and then we'll talk about what .send does. Okay. Does that sound good? I can't see you, so hopefully.
Sorry.
All right.
Yes.
Okay. All right. Sweet. All right. So let's bridge this gap real quick and start actually making some objects, and then we'll talk about how we could use .send, and it's just an option that you have. .send is great if you have inconsistent data coming in, and we'll talk about that in a second. So so we have create from API, and we called create from hash. We don't have that yet, so we need to make it. So let's say def self.create from hash. We're obviously going to take in a hash. Okay. And now we have a problem because the hashes that are coming in have a name and a URL. I need to have a type in a URL. And not only that, these keys are strings, my keys are symbols. So I'm going to have to format my input a little bit. So what I do is I'm going to say self.create from hash is going to call self.create. I'll use self.create, and I'm going to say self.format hash. All right. So again, I'm writing code that doesn't exist yet because it gives me a nice game plan. I know that I want to create from this hash, but I know I need to format it a bit. I need to turn this string name into a symbol of type, and I need to turn this string URL into the symbol of URL. So I'm going to say I can put this into create given that I've formatted it correctly first. Right? So I'm going to pass my array of hashes in here. I'm going to iterate over each hash, get one hash one at a time, call create from hash. My create from hash is going to accept a hash, and it's going to call create on a formatted hash. So to make all this work, all I have to do now is write a method which properly formats this hash into something that can be passed into create, which again changes the name string into a type symbol and changes the URL string into a type symbol. So let's do that. Def self dot format hash takes in a hash, and I want to say let's do hash. Oh, actually, who can tell me a cool iterator I could do here? How can I take in a hash and return another hash? Does anybody remember?
Collect.
Collect takes in an enumerable, but it'll return an array. But it's not a bad idea. It's actually kind of similar to collect, what I want to use. It's a more advanced one for sure. Anyone? All right, so there are two possibilities here that would work really well. Reduce or each with object. We're going to do each with object because it's a little bit easier, simpler to grasp at first, okay? What each with object does is it will iterate over any enumerable. Hash and arrays are both enumerables. So I can say hash dot each with object, and it's going to give me two things. Who can tell me what those two things are? Does anybody know each with object now that I've said it?
No.
No? Okay. So it's going to take an argument, and it's also going to give a block. That block's going to give me two things. It's going to give me whatever I'm iterating over, element one at a time. And it's also going to give me what I'm going to call mem. It stands for memoization, okay? So basically, what I'm going to say is each with object, I'm saying, hey, I want to build up this hash as I iterate through this hash. So it's saying, give me back at the end of the day this guy. And every iteration, I'm going to mess with whatever I'm iterating over to change mem. And mem is just basically keeping track of this original hash. And I'm going to keep building it up over every iteration. And at the end of the day, I want you to return to me whatever mem is. So mem gets recycled over every iteration. And I keep building it up and up. I'm starting it off as an empty hash. All right. And I'm going to build it up and up. Now, because I'm calling each on a hash rather than an array, I actually don't want just an element here, because when I do dot each on a hash, what do I get? I don't just get one thing. What do I get?
You get a key value pair.
Yeah, let's check this out. Key value. So now I'm going to have, let's put a binding pry here because this is going to get kind of crazy. All right, so let's see what we got here. What I'm doing, actually, you know what? Let's just run the code and just follow it through. See if we get any errors. Oh, you know what? I don't think I even said create from API in my API manager, which I definitely need to do. So let's take the binding pry out of here and say, yeah, we're just going to hit that one, which I don't care about. So I'm going to take out this pry and I'm going to say, let's require relative here. For now, let's require relative Pokemon. All right, cool. And I'll say Pokemon dot create, what did I call it? Create from API? Yeah. From API. And I'm going to pass in res, and I believe the key that I wanted was results, and it's a string. All right, cool. So I'm passing in this array of hashes into my create from API. I should iterate over them, and I should get my binding pry at the step where I'm trying to figure out how to format it into, and I misspelled each with object. Each with object, Very cool. All right, so I'm at the step. Let's follow the data here. I got my response. My response looked like this, right? A next, because I'm paginating, so it just gave me the first 20. It gave me the URL to get the next 20 Pokemon. the URL for the previous 20, which is nil, and then the results of this set of 20, okay? So I put in the results into create from API, and that's this array of hashes. Create from API, iterated over this array of hashes, got me one hash at a time, okay? Then I said, okay, I want to be able to create from a single hash. So I just made another method. I didn't have to do that here. I could have just said, you know, self.create, self.format hash right here. But you know what? Let's do that. Let's refactor that. I don't need to say create from hash because it's only one line. So let's go ahead and put that one line right there. So I'm saying, okay, for each hash, I want to create. But my create requires a type and a URL, and then these two name and genders, which are optional because they have default values of nil. So I'm saying, okay, well, if I need a type and a URL, and I need those keys to be symbols, but I'm getting a name and a URL, and those two are strings, I need to somehow format this hash to match what needs to go into create. You guys tracking that so far? Does that make sense? What I need to do there? Okay. So I hit my pry. So let's look at what my hash looks like right now. So here's my overall hash. Okay. It's a key of a string name and a key of a string URL. Now the values are what I want, except I want this key to be a symbol of type, and I want this to be the symbol of URL. That way I can just pass it right into my create. Do you guys get how, like, why I want to do that? Does that make sense?
I have a question. Now you have the name is string and the URL is a string type, right?
Mhm.
And the reason, why did you change it? Why couldn't you just say, okay, you know what, instead of making it a symbol, why can't you just put a string in there? Is it because then that changes, then it has to be, that's the placement of it? Is that why you change them to symbols?
The way these named arguments work in Ruby is that they have to be symbols.
Okay.
They just have to be. So if my keys are strings and I want to pass it in, if I want to do named things, now I don't have to do named things. I could have made these not named and just like said, like, you know, I could have done self.create, and then the first argument's going to be pokehash and the key of name, right? And then the URL would be pokehash with the key of URL. Like this would have worked fine. Like that, I would be done at this point. But I'm trying to show you guys, if you have a bunch of key value pairs, and it's not just two, this is going to get real tiresome really quick. So instead, it's really cool to be able to know how to set named parameters in your initialize and your create methods, and then format your data to come in to match those, so you can just pass it in right away.
Okay.
Right, rather than doing this. But do you get, like, this would work? Like, I wouldn't dock you points if you did this in your project. Does this make sense right here? Like if my create method was def create or self.create, and it was just type and URL like this, that's how this would work. And if the URL didn't have a colon there, I wouldn't even need the name here. I would instantiate like this. You tracking me? Does that make sense? Okay, cool. But what I want to show you guys how to, because you might have like, what if you have like 15 things, right? You want to make them all named, and then you want to format your input hash to match these. Unless you want to use .send, which we'll do after this. Where again, we'll set a hard limit at 15 after pod group. Bear with me, you'll get 15 minutes at the back end. But let's do it both ways, and then you guys can choose which way you like to do it. So name and URL. We want to turn it into a type, and I also like each with object. Getting your head around it just requires you to think about it and use it. So I want to introduce you guys to it so you can start practicing on your own. All right, so here's my hash. My key is going to be name. My value is going to be Bulbasaur. All right, and my memoization is going to be an empty thing. So because this is name, I actually want the key for Bulbasaur to be the symbol type. So I really want memoization of type to equal whatever the value is. Okay, and then I do exit, and I hit my binding.pry again. Hash is still the same because I'm going over both key value pairs. But if I look at my mem, see how it has that type of Bulbasaur because I explicitly said it before? My key is now URL, and the value is now that. So I want memoization now to have a key of my key, but in a symbol, to sim, and I want the value to still be value. Now if I look at my mem, that's what's going to get returned from my each with object, and therefore my format hash. And this can be passed in to my create because I have a key with a symbol of type and a symbol of URL. And that will work here. Does that make sense? So all I have to do is do what I just did in the console here appropriately here. So what did I do? I said if the key is equal to name, then go ahead and say memoization of type, the symbol type is equal to whatever the value is. So if its name is a string, I actually want that to be type. Otherwise, the memoization of whatever the key is to a symbol, take that string, turn it into a symbol, should be the value. All right, so now I should be good. So let's exit exclamation point. Let's take out our binding pry, and let's see if all went well. I should have an array of Pokemon after running my API manager.get Pokemon. I should have turned my API data into objects. All right, argument error. Wrong number of arguments given to expected 0. Required keyword type, and that's on line 31. Let's take a look at it. So I'm calling create. Okay, so whatever's calling create is passing in the wrong stuff. So let's go ahead and put a binding.pry. Oh, because I had this example line here, that's why. Okay, forgot to delete my examples. All right, undefined local variable SHS. All right, so I'm somewhere saying it, and that's on line 12. Oh, because I called it Pokehash. That's why. Yeah, seeing how I'm troubleshooting here, I don't want to do this too fast, right? So I had SHS here. I had an error, right? I look at the very last line of the error. It says on line 12, Pokemon.rb line 12, undefined local variable HSH. Okay, so I look at line 12, and I say, okay, well, I wrote hash here. What's actually the variable I wanted? And it was my local variable Pokehash. It's like, oh, I didn't mean to write hash. I just got confused because I was making that the variable name here. So I'm saying the actual data I want is Pokehash. You guys all tracking me? How I did that? You guys got to get good at that, right? That's going to save you so much time when you're making stuff. For being able to read those errors and quickly figuring out what you did wrong, valuable skill. All right, call the method create is defined here. Did I not delete my fake create? Lecture, Pokemon, RB30. Oh wait, hold on, that's just a warning. All right, so we just didn't hit a binding pry because I don't have a binding pry anymore. Binding.pry. So everything worked. Let's run it now. There we go. So if everything worked, my Pokemon.allArray should be filled with Pokemon. And it is. Okay? And they all have these names: Bulbasaur, Ivysaur, Venusaur, Charmander, with URLs. And URLs that I can go to get more information. So I could say def self.getInfo about Pokemon. Response equals httparty.get poke.url. Right? So I pass in the Pokemon object here. It already has a URL saved from this line. And then check this out. So if I say, okay, API manager.get Pokemon, and then I can say API manager dot get info about Pokemon.all.first. Let's see what that looks like. You guys tracking what I just did? I've
How
saved
were you
the
able to do poke.url?
Because URL is one of the things coming in. URL.
Yeah.
At
okay.
URL. Actually, Assessor. So that's one cool thing. I've now, part of my Pokemon object is now the URL. It can go out to get more information about itself. This is going to be, when we look at our example, when I make an example CLI for you guys, this is actually going to be a vital part of your thing. Because what you're going to do is, what I would do in a CLI here is that I would give you guys the choice to select any one of these Pokemon to get more information about them. But I wouldn't have that information yet. I would have saved the URL to get more information. But if I went out and got all of these guys' information right away, you would be sitting there at the beginning of my application for a long time while I went out and just got information about everybody, about all the Pokemon. So instead, I give you a set of Pokemon to choose from, And only after you've chosen one would I go to that URL and get information about it. So this object holds a way to finish getting data about itself without yet having it. All I have to do now is pass in a Pokemon object into this get info about method I made in my API. And then I go get the information about that URL. And then I could make another, and then I could use that information to set attributes of that individual, right? So I could say Ruby API Manager, we should hit our binding pry. We should hit this one first, hopefully. So let's make sure that happens. And our response should be a bunch of information about whoever is first, Bulbasaur. All right, good. We hit the right binding pry, line 17. And if I say res, I should see a bunch of data about Bulbasaur. Yeah, and there it is, right? Abilities, chlorophyll, right? So here's all my Bulbasaur information. Because my Bulbasaur object had a URL saved inside of it that was like, hey, go here to get more info. So I was like, okay, great. My API manager should be in charge of that. So I'll get more information about some Pokemon. I know the Pokemon knows what URL to go to get more information. And I get that information from the internet. And then I can use all of this data to populate that object with a bunch of data. Cool? All right, let's talk about, let's take our 10 minutes before I have to end here to talk about send and an alternative way to do this, okay? So I'm gonna make a Pokemon class right here that's gonna be really lightweight. So we're gonna get rid of this guy here. We're just gonna make a class of Pokemon. All right, so let's say our initialize, okay? And we'll say hash. So let's say our Pokemon, all right, wants to have a name, a URL. Actually, let's say type to keep it. No, let's keep it name. Okay, so this time I want to match up with whatever is coming in from the API. So name, URL, and that's it for now, just to keep it simple. All right, so we know that the data that comes back, right, is going to look like this. It's going to look like, where is it? There we go. Name and URL. But let's say there were some times where like some Pokemon didn't have a URL, or maybe some didn't have a name. Obviously, that wouldn't work for this case, but there might be times where your APIs come back and you have like maybe 6 or 7 key value pairs and they're not consistent with what they are. So like out of the possible, like let's say there are 10 possible key value pairs per single object. But let's say you're not always guaranteed to get all 10. Sometimes you'll get like 7 out of the 10. Sometimes you'll get all 10. Sometimes you'll get 6 out of the 10. This is where send becomes really nice. Because what I can do is say, okay, well, I can just make attribute accessors for all the things that I could get. And then I could pass in a single hash into initialize. And now I can use self.send to write whatever it is the hash gave me without knowing it. Now, you could also do it my way, which I personally prefer, and just give no default values here. But send is also another great way to do it. So what send will do is, actually, does anybody know what send does? Who can describe what send does to me?
Send will call the method on the string and set it to the value that you pass it in.
Yeah, exactly. It calls a method that has the same name as the string I pass in. So real quick, if I just like went to IRB real quick, all right, and I made like a class of dog, and it won't even have an initialize method, but it has an instance method called bark that's like puts out bark. All right, so now if I have a d equals dog.new, okay, and I want to say d.bark, that worked, right? Bark. I could also have said d.send the string bark. It's going to call the method of whatever string is that I pass in here. All right, and you might right now be saying like, why would I ever want to use that? Well, this is one reason why. Because I don't know which key value pairs are coming in. Let's say it could be name, it could be URL, it could be both. Or, you know, if I had like 7 or 8 things, it could be any combination of those 7 or 8 things that could come in. So since I don't know which key value pairs I have, I'm going to dynamically call the writers of whichever ones it happens to give me. So I'm going to send, so I'm going to call the method, I'm going to use string interpolation of whatever my, actually, you know what, let's iterate over the hash first. So I say hash.eachDo, I'm going to get a key value pair, and I'm saying for each key value pair, right, I'm going to send whatever the key is, so if it's name, the writer method, and I'm going to set it to whatever the value was, right? So if that hash that's coming in, right, was name, or actually it was a string, so name of Bulbasaur and a URL of, you know, HTTP, Pokemon stuff, Bulbasaur, whatever. So what I would do here is if that was the hash that came in, I would say hash.each do. I would get the key and value pair one at a time. So the first one would be name and Bulbasaur. And I would say, I want to call on myself the method name equals. I'm interpolating the key and I'm then putting an equal sign afterwards. So that's going to call the writer method the attribute accessor wrote for me. And the argument I'm passing in is the value. So basically that's the exact same thing had I said self.name equals whatever the value is. Okay? The only thing is, because I didn't know which key it was, I couldn't explicitly say .name because what if .name wasn't one of the keys, right? So this is a great time when I'm saying I know all of the possibilities it could be, but I don't know which ones won't be there. So I don't want to explicitly call name equals because there might not be a key name equals, right? So instead, I'm going to just, whichever keys I end up getting, I'm just going to send those to myself, call the writer method for it, and pass in the value. Again, that's the exact, that in this case, if the key was name, be exactly the same, saying self.name equals, passing in the value. Of course, the real way to write this is like this. Any questions about that? I personally don't do this very much unless I have to. I think send is great in certain use cases. I personally don't think, unless you're doing like, I've used send when I was doing like I don't know, it doesn't matter. But I'll show you guys some other times. I mean, you definitely can use send. I'm not saying not to use it. I personally probably do something more like this. I think it's like clearer, but send's fine. Now the thing with send is you have to be careful that you're not trying to send something that isn't up here. If you try to send a key that doesn't have a writer, you're going to get a no method error.
Yeah, I
Right.
ran into that in my program.
Yeah. So you got to make sure that if you're using send, your attribute accessor has to include all of the possibilities. Okay? Any questions about send?
So would you say that send is more for like actually scraping instead of APIs?
It really depends. I would say that send is great if you're getting inconsistent data, whether that comes from an API or scraping. You can really get some, usually APIs will be more consistent as a general rule, but there are some that are not. So I would say, yeah, as a generality, yeah, I would say probably more for scraping than APIs. However, if you're in a situation and your API is giving you some keys sometimes, some other keys some other times, put them all as attribute accessors, and using send is fine for that as well.
Okay.
That makes sense?
Yes.
So let's see if this works, right? So basically, I'm going to say create from API here. I'm going to use this local little Pokemon class, just make sure it works. So I'm going to say def self.create from API. I'm going to take an array of hashes, and I'm going to say array of hashes.each do. I'm going to get one hash one at a time, and I'm going to say I'm not going to do create anymore. I'll just say new from API because we're not going to do like an audit all method and all that good stuff. So we're going to say new from API. We're going to get array of hashes, iterate over each hash, and now I don't have to worry about formatting it because I made my accessors the same as the strings here, and I'm sending the name equals method. All right, so I don't care that they're strings anymore because the string will be turned into a method call. All right, so now I can just say new, pass in the hash, and I should be good to go. And actually, I will say create because I want to be able to put a binding.pry and see all the ones that we've made. So let's just go ahead and do that real quick. Add all equals empty array, def self.all returns add all. All right, and then in this, well, actually, no, we'll just go ahead and say def save, add all, show oneself, and then a def create. It takes in a hash and literally just says p equals new hash, p.save, return p. All right, cool. So now we're doing that, and now we're creating, and we're going to call create here instead. But anyway, same thing. I just put some boilerplate around to make sure that added all array was there so we can see them all. But ideally, this would work just fine. So let's see what happens. We're going to call that. We're going to get our binding.pry down here. Let's take out this. I don't want to do that right now. And I should get a full added all array of Pokemon with a name and URL. and I did not want to do IRB. I wanted to run the program. And if we get an error, I'm going to ask you guys to help me troubleshoot. Okay. What's this? Why did I get this error? How do I fix it?
Because you changed your call to new from API.
Okay, what line is it on?
49.
There you go. All right. So that's what every time line and then the error, and exactly right. I made the decision to change from new from API to create from API. I decided to put the added all array there so we could actually see all of them. And I didn't change it here. So I got the error on line 49. I go down here, very clear that I said new here and I said create up here, right? So again, great skill. Hey, good job getting that figured out so quick. That was good. All right, how about this?
It's on line 15.
Okay. What's wrong?
Undefined method create.
Okay, what did I do wrong? I see a create method right on line 19. What's wrong with it?
That's an instance method, not a class method.
Exactly. Undefined method create for Pokemon class.
Oh, okay.
There's no self dot here. There we go. Good call. There we go. Binding.pry. So if I say Pokemon.all, there they all are with their name and URL, right? Completely different way to do it, just as valid, right? I make my attribute accessors. This is the only time where I will be okay with you not putting your instance variable set up in your initialize if you're sending it. I don't like it, but I'll be okay with it. This is, I don't know. For me, sending, I only do it when I have to. It's a little bit hackish. It's a little bit cowboy-y, shoot from the hip for my taste, but it is cool. There are some times when it's very, very useful. So I'm not saying don't use it, but I'm saying don't overuse it. Definitely a fine way to do it. And as you can see, it works just fine. Any questions about how that worked? Any questions about anything that we did today?
I mean, obviously, this stuff is confusing, but I guess with good practice, we'll be fine.
Yeah, and so one decision I always make here, let me stop the recording. So I'll kind of send you guys off in a second.